All right, thank you for joining us today. And in this video, we are going to practice on average and instantaneous rate of change. Let's jump right in. So we have this question where we have our S of t, and then we have this table right here that we have the time intervals, and then we need to calculate for the average velocities, right? Then when we are done, we are going to look at the trend to determine the instantaneous rate of change. So as usual, first we need to write down the formula, right? But the function given to us is in terms of S of t. So we are going to have average rate of change to be equal to S of b minus S of a divided by b minus a. So here what we are going to do is we are going to pick this interval, we solve, then we pick this interval, we solve, we pick in that order. So let's pick the first one. Okay, so the first one is 1 and 2, right? So our a will be the first value and our b will be the second value. So it means that we are going to have the average rate of change to be equal to S of 2 minus S of 1 divided by 2 minus 1, and we are going to have S of 2 minus S of 1 divided by 1, and this is going to give us S of 2 minus S of 1, right? So we need S of 2, right? So as we said, the strategy holds. We need to pick the function, which is S of t, which is equal to t squared minus t. And here we need to put all the t into what? Parentheses. So t squared minus, good, which is going to help us to solve the values. So now let's look for S of 2, right? So what will be S of 2? S of 2 will be equal to 2 squared minus 2, good, and this is going to be 4 minus 2, which is going to give us 2. Then let's look for S of 1. S of 1 is going to give us 1 squared minus 1, which is 1 minus 1, which is going to give us 0. So we are using the same function here, and when you put it inside parentheses, that's all. We just, everything in the parentheses will change to the new value in the parentheses. So we repeat the same function there. So it means that we are going to have, this is 2 and 0. So here we are going to have 2 minus 0, which is going to give us 2. So the first box we are going to have 2, right? Now let's look at the second box. The second box we need from 1 to 1.5. So the average rate of change here, b is 1.5 and a is 1 divided by 1.5 minus 1. Let's simplify. Minus 1 divided by 1.5 minus 1 should be 0.5. So from here we have the S of 1 already. So I think all we need to do is to do the calculation for the other side. So let me bring this one down. I think this is 0. So let's put it here. And let's look for S of 1.5. So S of 1.5 will be equal to, so we are just changing the one in the parentheses to 1.5. 1.5. Good. So when I square 1.5, I'm going to have 2.25. I think I'm right. And then this one will be 1.5. And then when I subtract 1.5 from 2.5, 2.5, 1.5. So 5. I'll borrow here becomes 12, then become 1. So 7, 1 minus 1, this one will be 0. So you are going to have 0.75. Good. So we are having 0.75 there. So let's go and plug them in. So we are going to have 0.75 minus S of 1, we had 0. So it's 2 0 divided by 0.5. So 0.75 divided by 0.5, and this is going to give us 1.5. So the second box is also going to give us 1.5. So it's the same process. So the next interval that we need to also work on it is we need to work on the 1 and 1.1, right? So still we have our 1 to be 0. So the average rate of change is going to be s of 1.1 minus s of 1 divided by 1.1 minus 1, which is going to give us 1.1 minus this. 1.1 minus 1 will be 0.0. So here from this one we just need s of 1.1 because we know s of 1 already. So let's look for s of 1.1. So the same thing, 1.1. So 1.1 squared minus 1.1. What is 1.1 squared? 1.21 minus 1.1, and 1.21, then 1.10. This one is subtract, I'll get 110. So this one 0.11. So let's go and put it inside. So 0.11 minus 0 divided by 0.1. This is going to give us be 0.11 divided by 0.1, and this is going to give us 1.1. So the second box is also going to give us 1.1. And then the last one is 1 and 0, 1 and 1.01. Okay, so now let's look at the last one, then we can conclude on the instantaneous rate of change. So 1 and 1.01. So the average rate of change for that one will be s of 1.01 minus s of 1 divided by 1.01 minus 1. Simplify. So we are going to have 0.01. So we need s of 0.01. So let's come and work on it here. So s of 1.01 will be equal to 1.01 squared minus 1.01. Good. 1.01 is 1.0201 minus 1.01. So let's try and 1.0201. Then here is 1.0100. So when I subtract, this one will be 1, 0. This one will be 1. Okay. So 0.00101. Okay. So let's 0.001 minus 0 divided by 0.01. This is 0.0101 divided by 0.01, and this is going to give us what are we going to get? So if I move this one 1 2 1 2, okay, so we get 1.01. Good. So this is also going to give us 1.01. So now these are the average velocities, but let's look at the instantaneous rate of change. Now we can see that all the values, the initial values are all 1 1 1 1. It means that there is a change, which is h. So the more h is getting to 0, because if I have 1.01 and it means that it's almost 0, the change is almost 0, then what is the average velocity approaching? The average velocity is actually approaching 1, because at this point, when I find the approximation of this one, it's just 1. So we can see that if we even pick a value like 1 and 1.00001, you will see that this one will be like 1.00001, which is approximately 1. So it means that with this one, the instantaneous rate of change, or the instantaneous velocity, will be equal to 1. Yeah. So what did we do? For us to calculate for the instantaneous rate of change, we need to calculate for the average velocities before we can conclude on instantaneous rate of change. So we had the function, and then the trick was we need to put it in parentheses, all the t's in the parentheses, and then we did, and we started calculating from this interval, this interval, this interval, and this interval, and we had this, and based on this we saw that this is actually approaching 1, and we concluded that the instantaneous velocity is going to be 1.